All right, hello and welcome to Data Engineers Lunch number 115. Don't forget to like and subscribe, as well as turn on the notification bell so you get notified when we post new videos or go live. Today's topic is resilient data architecture with Amazon RDS, Aurora, and DynamoDB. We'll learn about Amazon Managed Database Service, how to use them to build resilient data architecture. Our speakers today are Saikat, the Senior Database Solutions Architect with AWS, and Sujan, who works with IDEXL as a solutions architect. The organizer of this event is Rahul Singh. If you are interested in being a co-organizer or want to help get speakers, you can reach out to us at the email listed below, marketing@anant.us. If you are interested in giving a talk, you can reach out to us at that email as well. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is a collection of other organizations generally centered around data. You can find out more at datacommunitydc.org or dc2.org. At Data Engineers Lunch, we cover everything for the ingress and egress of data. Excuse me 1 second. I gave this whole spiel without actually showing you the associated slide deck. Here we go again. So just to cover things that we've already talked about, this is Data Engineers Lunch number 115. It's about building resilient data architecture with Amazon RDS, Aurora, and DynamoDB. Our speakers are Saikat and Sujan from AWS and IDEXL respectively. Organizers Rahul Singh. You can contact us at marketing@anant.us if you are interested in giving a talk, finding speakers, or becoming a co-organizer. Data Community DC. Data Community DC is a collection of other organizations. Okay, we're back here. At Data Engineers Lunch, we cover the ingress and egress of data and everything in between. Remember, again, to like and subscribe, as well as turn on the notification bell. If there is anyone who would like to say hi, what brought them here, what they do, or what they hope to get out of this, you can leave a message in the chat. Our group rules: if you have a question, ask it. We will take questions at the end of the presentation, so stick around until then. If you leave a question in the chat, be polite and courteous to others, and share what you know. We would like to give thanks to our program sponsors, our institutional and organizational sponsors. 15 seconds for announcements. If anyone has jobs, meetups, hackathons, or conferences to announce, this is time. You can put them in chat now. This Data Engineers Lunch happens weekly on Mondays at noon, as well as Cassandra Lunch, which happens more intermittently on Thursdays at the same time slot. Our Anant runbooks are still available. If you would like to get Anant runbook 17, you can find them at anant.us/runbooks. And if you would like to download them, the link is in chat. All right. So I will pass it over to our speaker for today. Go.
Thank you, Obi. Let me quickly share my screen. Right. I hope everyone can see my screen, right?
Yes.
Okay, cool. Hi, everyone. Nice to meet you all virtually. So today's agenda looks like we'll focus on the data source side, right? As Obi showed, the entire data pipeline or data flow from source databases through data processing, ETL to the target right side. We'll focus on the source side, like or primarily transactional data sources, like which are RDS, Aurora, or DynamoDB. So we'll understand the managed databases landscape primarily, or offering we have available, and we'll understand why resiliency is so important topic in the cloud architecture. Then we'll understand the resiliency capability and best practices in RDS, Aurora, DynamoDB. Sujan will walk us through some of the patterns or common architecture, how they work together, and we'll see a quick demo and we'll take question answer. Okay. So minimize this slide. Yeah. So as everyone of us know, right, the data is growing exponentially, right? It's not uncommon to see applications running on terabytes of data, even growing to petabytes or exabyte scale, right? And the database size is growing, data is being fed from different sources, applications, patterns are going are being different, like ad hoc applications, online transactional applications, IoT devices, or connecting to different kinds of application, global applications. So the patterns of applications becoming diverse and used by many people, right? Different business units, different job roles. They want to use the data from the databases and analyzed by different applications, right? So like 30% average annual growth of a data-driven business from a Forbes article. So it's the organizations becoming more and more data-driven, and it's very important to choosing the right data architecture. And to support this kind of workload and application requirements, right, it's very difficult to achieve that with legacy data infrastructure that needs a lot of undifferentiated heavy lifting, right? So significant amount of part of on-prem workload, they are spent on hardware, software installation, operations, and management. So you get very little time to build new feature and capability for your business. So most of the time you spend on capacity planning, maybe you have running self-managed clusters, managing security compliance. So that hinders the growth of your organization as well as your job, right? So with managed database services like relational database service like RDS or like fully serverless databases like DynamoDB, right? You can definitely increase the efficiency of your operations, right? Uh, you can do more work on the development and feature side rather than mundane keeping the lights on. So you manage less, so you can innovate more with data, and by doing that, choosing the right architecture, you also reduce the cost of your data infrastructure. So you can focus more on innovation. So how does the job role changes or day-to-day operations or day-to-day work changes when you move to something fully managed database service like a relational database service, right? As you see on the right-hand side, AWS takes care of most of these operational heavy lifting work, right? For example, it provides automatic failover capability for any interruption in the host or AZ. It provide you one-click scaling options, right? It provides you automated backup recovery, all the tooling and underlying heavy lifting process we take care of. But in many cases, you have the control and options to turn on or choose the right options and right capability as per your requirement. So most of the time you'll be spending with managed database services on schema design, maybe writing better query, designing the data model or optimization. This high value work than rather than keeping the lights on, right? Although today's session will focus on primarily the data source area like Amazon Aurora RDS and Amazon DynamoDB, with AWS, you can basically achieve the end-to-end data journey, right? From source through application for databases for application, through your data tools for ingestion, like streaming services like Amazon Kinesis, Amazon MSK, through operational analytics with OpenSearch service, as well as you can do heavy analytics or aggregation through massively parallel processing data warehouse like Redshift, and build your data lake on Amazon S3. And ultimately, you can build your machine learning models and capability through like services like SageMaker or Amazon Bedrock for GenAI capabilities. So basically, AWS database services or data services helps you store, query, analyze through our database and analytics services. And later you can act on those data through our machine learning services and business intelligence services, right? Ultimately, which are used by people or different kind of apps or devices. And all these can be governed and cataloged through AWS Lake Formation. So basically, you can achieve your end-to-end data journey through a comprehensive set of services for your data foundation. So due to limited time and scope, today we'll focus on this Amazon RDS, Aurora, and DynamoDB. But looking forward to hear your feedback for follow-up sessions on any of these areas. So those who have not used RDS, right? RDS or Relational Database Services helps you set up, operate, and scale relational database in the cloud with just few clicks or a few API calls, right? And it significantly reduces the burden of creating and managing clusters and databases on-prem. So it supports different engines, as you see, from commercial engines like Oracle SQL Server to open source Postgres, MySQL, MariaDB, as well as cloud native databases, part of the RDS family with Amazon Aurora. And it's pretty mature service. It's 2009 first the RDS engine was launched, and it's 10 plus years operational experience and expertise, implementing all the security and scaling best practices and innovation. And you can also get high availability with few clicks, right? With by turning on multi-AZ, and you can choose the right database engine. And also we have currently supported DB2. So it is not like DB2 is not there in the slide, but since last reInvent, we also support DB2 as an engine in the RDS family. So it's you can pretty much get all kind of engines you need to get supported for building application, and you can get started with like building easily. So quick introduction on Amazon Aurora. It's basically the capability of high-end commercial databases from an open source price point, right? So when you started building RDS services, right? So like customers wanted to get the capability of high-end commercial databases from a open source um, like simplicity and cost effectiveness of open source databases. So Amazon Aurora is a cloud native fully managed databases that is designed for high performance and availability at global scale with fully compatibility with MySQL and Postgres. So it provides all the high performance capability you need to run your mission critical applications with decoupled storage and compute. And it comes with all the enterprise class security features and availability features like encryption at rest, in transit, and like up to 4 nines of uptime SLA and multi-AZ capability. And you don't need to manage your host, right? So it comes, it's only pay as you go model, right? You only need to pay what you use. And it also comes with a serverless offering, which automatically scales up and down instantly. And when you'll be using a database, it will not be in the island, right? It will have to interact with other services like S3 or for ML services, for example, Amazon SageMaker Comprehend, right? All these integrations are provided here. So we got a brief overview of the services, Amazon RDS and Amazon Aurora, and why resiliency is important, right? So, like, what do you mean by resilience? Your data resiliency. So, resilience is nothing but your ability of your workload to withstand partial or intermittent failure across components, and eventually how quickly you can recover from those unexpected conditions. And it boils down primarily to two areas. One is the high availability, and then the disaster recovery. So high availability, you need to have automatic failover capability, which is usually in region, right? For example, multi-AZ does provide the high availability capability in RDS. So it's basically resistant to common failure through design and operational mechanism. And for disaster recovery, it's primarily tied to a disaster. For example, if a region goes down, right? So entire region, maybe for natural disaster, right? How quickly you can bring your application or services up and running. So you may be a data engineer, primarily pull the data or build your pipeline from these data sources. So if your data sources are not highly available, your pipeline will be delayed or maybe errored out, and your business will not get the data at the right time. Similarly, for a region outage, right? If there is a disaster and your data pipeline goes down, your executives or business users will not get the data timely, and that will impact ultimately your business decision, right? So that's why it's very important. So let's quickly understand the high availability capability with Amazon Aurora, how it is architected and how best you can leverage Amazon Aurora clusters for high availability. So if you take a look at the architecture in the Aurora cluster, right, it's the compute and storage node are decoupled, right? So the SQL transaction and caching taken care by the compute nodes, and logging and other many operations like heavy lifting backup and self-healing capability are embedded in the storage, right? So it uses the distributed log structured purpose-built storage architecture. So it is distributed across 3 AZs, each AZ 2 copies of data. And as you see, in a single cluster, there is one read-write node, and you can have up to 15 reader nodes, right, to scale read scalability, right? And backups are continuously sent to Amazon S3, and so that you can quickly recover, right, from backups, and it is automatically enabled. So how Amazon Aurora Storage helps you achieve like fault tolerance for AZ+1 failure, right? As I mentioned, the data is written across 3 AZs, right? 2 copies each AZ. So for write to be successful, 4 out of 6, right, has to be successful to achieve a write quorum. So for example, there is AZ3 is down, then it can still write up to 2 AZs, 4 copies, right? So for example, now AZ3 also down, maybe 1 copy or one segment is also down, then it can write 3 out of 6 copies. So write maybe paused for a few seconds then, but it quickly recovers through peer-to-peer gossip protocol, and your write continues, right? And read always continue, and like, because it doesn't need to go through the quorum path. But for recovery, for example, node restart or so, it needs to do 3 out of 6 recover reads, right? So even AZ+1, the read can go through. So the self-healing architecture rebalances the storage nodes, rebuild the segment from failed hardware quickly. So that's about the storage layer, right? It's inbuilt. It provides you the capability to do that like highly available architecture from storage standpoint. But what about compute nodes, right? So from compute side, you can have one writer and up to 15 readers, right? And for connecting to writer, you provide a cluster endpoint, and for connecting to readers, we provide a reader endpoint that in a round robin fashion distribute the load among all the readers. So in case there is a host issue, for example, a faulty underlying EC2 instance or maybe EAZ issue, it will automatically fail over, and the cluster endpoint will point to the newly promoted writer, right? Now, if you have multiple reader, you can choose something failover tier that will determine which reader will be promoted as a writer. The lower the tiering you provide, the higher the chance of being a writer. In this example, we have provided 0 as a tier to the original reader, so it became the new writer, right? So that's about the high availability capability in Amazon Aurora by creating instances in different AZs. For best practice, one writer and 2 reader distributed across 3 AZ is the highest available architecture. You can ensure that even for an AZ outage, it can fail over, and still you can have a failover reader-writer pair, right? So for best practice, we recommend deployment in 3 AZ, one writer, 2 readers. What about RDS? Other RDS, for example, RDS open source or RDS commercial, right? So we have 2 deployment models for high availability. One is multi-AZ with 1 standby, and multi-AZ with 2 readable standby, or multi-AZ cluster. So we call it multi-AZ cluster with 2 readable standby, and multi-AZ instance with 1 standby instance. So this one available for all RDS engines, right? Including like open source, MySQL, MariaDB, Postgres, or commercial like SQL Server or Oracle engines. And this is available only for open source engines. So let's understand what capability it provides, right? It provides basically synchronous physical storage level replication, block level replication to second AZ, and it will provide automatic failover instantment, and typically 60 to 120 seconds is the failover time. but it can be longer if the DB is very busy and there is a crash recovery going on, right? And this is multi-AZ means they're physically in distinct independent infrastructure, right? The AZs are basically separated by miles apart and in independent group of data centers, right? So you provide like separate power, cooling, and independent infrastructure, and it's synchronous replication between them. So for example, understand the availability in a single AZ architecture. So you have your database in AZA and your app servers in different AZ, right? And for example, there is an outage, right? And so it will take minutes to uh, to to uh, to come back the instance. For example, if there any faulty hardware, we need to replace the host, or in case there is an AZ outage, you need to restore a snapshot, right? So uh, for you will have prolonged outage in minutes, right? In case of a host issue, or maybe longer if there is an AZ outage, right? So if the whole AZ goes down, then for multi AZ, it will basically like provide a synchronous physical replication. For example, as you see here, uh, it has a secondary instance standby being replicated in zone B or AZB. So for example, there is an issue in outage that will be promoted to primary. Endpoint will remain same. You don't need to make any changes in the endpoint, and it will start replicating back to the old AZ. And in case it's a faulty hardware, it will just replace, right? So automatically. So you keep your endpoint same, no change in the application side. Within 60 to 120 seconds, your application's back up and running. And without any manual intervention, your database became highly available, right? So there are so many benefits to turning on multi-AZ. Yeah, for example, you want to do like maybe maintenance, right? So system upgrade, OS upgrade, maintenance you need to apply, or maybe you need to do database scaling with host basically instance scaling for with multi-AZ. It first gets applied to the standby instance, then it does a failover, reduce the downtime, then it applies in the um, new secondary AZ after failover, right? So, and the endpoint remains same, and it provides 99.95% monthly uptime percent SLA for multi-AZ. So multi-DB cluster with two readable standby. So in some cases, you need to also have a read replica, right? So we need to have AZ, multi-AZ for HA or high availability, but you also need to scale your reads with read replica. Also, in some cases, you need to have a much lower downtime and much faster latency for your applications, right? For those use cases, this architecture may be the better fit or right fit. So how this architecture is architected, right? It's basically 3 AZ deployment. So your primary database is there, and it has a locally attached NVMe storage, and there are read replicas in different AZs, right? And and they also have locally attached NVMe storage so that the logs get written synchronously. And as long as the data is written in any of these instances, your writes are durable and your commit goes through. So basically, since it's written to the locally attached NVMe storage, the latency is much lower, and it uses native database replication, right? For example, it's a streaming replication, or it's a like semi-synchronous binary log replication. So it replicates lower amount of data. So it provides lower latency, it provides lower failover time, and also it basically it does provide read capability. So what's the benefit here for this architecture? In case you need to already have two readers, you can just use them for high availability. You don't need to have additional HA configuration, right? And you'll get lower failover time, and you will get also like lower latency from synchronous write. So here's a quick summary, right? And basically, the failover duration typically is lower, all right? And in single AZ, there is no failover applicable, And since right in this case it's written to the locally attached NVMe storage, right? So it's not that sensitive to the EBS jitter or elastic block storage jitter, right? And so, but in this case, it may be sensitive to impairments in the write path, right? And it uses 2 out of 3 quorum, so it's more tolerant to such jitters, right? And each of them can have 15 regional replicas, and it uses the native database replication mechanism. So we talked about the database level architecture. What about application level, right? So what are the things you need to take care from application side? So primarily, you need to ensure applications deployed in different AZs, right? And also you need to monitor the database events, for example, any failover or any impairment. All the events you can subscribe through SNS topics. And from application side, you may want to uh, uh, tune the TCP key FLI parameters or the JDBC connection settings, also that the DNS caching, right? So that it connects to the new instance after failover quickly without caching the old IP. And also, there are new drivers built by AWS for MySQL and PostgreSQL that basically understands the Aurora cluster topology. And without the delay in DNS propagation, it can quickly connect to reduce the failover time. So all these best practices from the application side you can implement so that you have minimal impact on failover or disruption. Then another best practice is having a proxy or connection pooling capability. So RDS proxy provide fully managed, highly available database proxy, and it not only provides connection pooling capability, especially if you're connecting from services like Lambda, where you cannot put a proxy in the host, right? So you can use RDS proxy endpoint to provide connection pooling, and it also reduces failover time so that it doesn't need to go through the DNS propagation. It can directly connect to the reader and writer. And also you can implement TLS configuration and SSL or TLS configuration and versions in the proxy layer. And it's a highly scalable and fully managed experience, right? So how it handles the failover disruptions, like idle applications connections are preserved by the proxy. So you don't need to, they will not be disconnected. Active in-flight transactions will be interrupted and you need to retry. But new request will be queued up in the proxy layer. So you can up to 66% reduce the failover time by putting a proxy, RDS proxy in front of your database, right? And some other best practices we launched recently was the RDS blue-green deployment, right? So many cases, for example, upgrade or like especially major version upgrade, or maybe schema changes, or maybe you want to do some uh, instance scaling, right? Those cases, you may have a prolonged downtime in the primary or production clusters. In blue-green deployment, you can a green deployment with a fully managed blue-green deployment, and you can scale those instances or upgrade those instances or make schema changes there. And in that way, simple, safe, and fast way, you can make those changes with minimal downtime to your applications, right? So what it does basically, for example, you have a blue cluster with blue read replicas, and when you deploy a blue read deployment, maybe with the upgraded versions, it deployed the same architecture in the green environment. And once you do a switchover, it pauses the write operation, disconnects all the connections, and basically then it will switch the endpoint. The same endpoint will be kept to the new primary. It will become the new production environment, and it will keep the old environment as a old endpoint, right? And you can delete that. So basically, we'll provide a fully managed logical replication capability to reduce your downtime um, from upgrade, especially major version upgrade, scaling, and other maintenance operation. So let's understand the business continuity and disaster recovery capability, right? So far we talked about in the same region, right? Mostly high availability area, right? How we can improve availability or applications in the RDS side or Aurora side. What about business continuity or disaster recovery? So, which is primarily determined the architecture by RPO or recovery point. That means how much data you can lose, you can in case of a disaster, right? Or if a region goes down, and how much downtime you can afford, which is RTO or recovery time, to bring up your application, right? How quickly. And depending on different RPO and RTO numbers, there are different disaster recovery strategy, right? If it is in hours, you can choose a backup and restoration capability, and maybe if it is in tens of minutes, you may choose like global database or with headless secondary. That means we'll talk more about the global DB architecture. It's basically the storage is there, data being replicated, but there is no instance connected to the Aurora global database. All right. So, and warm standby means maybe you are using global database near real-time replication, but smaller size compute. Hot standby, basically same size of compute, so that you don't need to scale in case of a disaster, right? So let's understand the backup and restore capability you will get from Aurora, right? And RDS, right? So you can have automated backup, right? In RDS, you need to turn it on, and you can set the retention period, how long you want to keep, right? And you can return up to 35 days, and no impact on performance or service disruption, right? And you can also take manual snapshot, right? And once you restore, it will create a new instance or cluster. In RDS, it's primarily instance, and Aurora, it's always a cluster. And you can also copy the snapshot to another region for disaster recovery, right? So um, um, and for copying, you can share the snapshot in same region and across accounts. In some cases, for ransomware protection or maybe for unscrupulous access to your primary account, you may want to share with other account or bunker account, right? Snapshots. So those capabilities are available, and you can also use AWS Backup to achieve some of this capability. AWS Backup is a separate service which provide fully managed single pane of view for all your backup operations across your services, including database services or EC2 or EBS services. Uh, Due to lack of time, we cannot dive deep today in the backup AWS backup service, but we'll be happy to cover that in any follow-up session if you're interested. And there are situations when you might have by mistake dropped a table, right? Um, so for example, you dropped a table or you ran a delete statement without a where clause, right? So how do you recover from such errors? So Aurora MySQL does provide a capability called backtrack, where you can rewind your database to a older timestamp. For example, at T1, maybe uh, at T2, maybe you dropped something and you want to rewind your database to T1, right? So we make the logs invisible to get your database back to the original timestamp, right? So this is very helpful for user-related error in Aurora MySQL. So due to lack of time and topic details, right, we're covering about 200, 250 level today. But if any specific topics, if you see you want to dive deep further, so we'll send a survey, and please like provide your input, and we can do a follow-up deep dive sessions on any of these topics if you're interested. So point in time restore capability, it basically let you restore to any point in time within 5 minutes, last 5 minutes in RDS, right? And it's in region, all right, and same account. So basically, if your backup retention maybe for 7 days, you can go back any time window within 7 days, latest at a 5 minutes window, right? Basically, it restore the snapshot, latest snapshot, and then we apply the transaction logs in the RDS, right? So what strategies you want to take for disaster recovery? That will be governed by uh, all this your RPO and RTO requirements, right? If it is in hours, maybe backup restoration may perfectly work for you. If it is tens of minutes, maybe pilot light architecture. And if it is in seconds, then maybe you need to have a hot standby. So with a global database with same compute capacity, right? So to understand the global database, it provides capability to have a disaster recovery plan, right, to low RPO and RTO across regions, and also data locality. Since your data being like replicated across regions, you can read quickly, right? You get a faster read, read latency across regions, especially your application geographical distributed. And you can basically rotate your workload across geography, right, by performing switchover. So for example, in this architecture, you see your primary application deployed in the Ohio region and other secondary regions and Oregon, Northern Virginia, Ireland. So you can have up to 5 secondary region and typically less than a second cross-region lag, and it will provide you faster recovery and high throughput, right, experience. So here is a summary of all the HA and DR options. As you see in multi-AZ, it's the same region, it's a synchronous replication. So 0 RPO, failover about 1 to 2 minutes, right? And cross-region Aurora global database provide, in case of Aurora, like it's less than a 1 second, and RTO with about a minute or around that, right? But for snapshots, it will depend on the when you took the snapshots, and RPO will be determined by that, and it will also depend on how big is the snapshot, right, to restore, right? So it will depend, all these things will depend on how much data you need to rewind, for example, in backtrack, right? There are some variable factor, but this provides a summary of all the HA and DR options with RDS and Aurora. So to summarize, at high availability, you can, by default, it's 3 AZ deployment, but the compute layer you need to take care of by having your compute nodes at different AZs in Aurora, right? And for multi-AZ, one standby, basically it's automatic failover, right? And 2 AZ deployment with 2 readable standby or multi-AZ cluster, 3 AZ deployment, faster recovery, faster failover, right? And also performance improvement. RDS proxy, it's basically it reduces the failover time, also manage connection pooling, blue-green deployment, any planned maintenance, you can reduce the downtime by leveraging that. For disaster recovery, there is backup recovery, backup restoration, cross-region read replicas. In case of RDS, for Aurora, it's global database, and also user error, you can get rid of issues from user errors using backtracking Aurora MySQL. So there are different features and capabilities for different kind of resiliency. And with that, I'll quickly get into the DynamoDB capability, right? Because that summarizes pretty much the resiliency features in RDS and Aurora. So DynamoDB provides a NoSQL fully managed serverless database, perfectly fit for key value kind of lookup kind of key value workload, right? And it provides performance at scale. That means, unlike relational databases where as the data volume grows, you need to take a lot of changes. Maybe you need to use parallel query, or you may need to partition the data. You need to take a lot of steps. DynamoDB, it provides same single digit millisecond latency, even if your performance scales, if your data volume grows, right? So it provides massive scalability and 5 nines of availability with global replications, and it fully serverless. That means you don't need to worry about patching and upgrade downtimes and so. And it also provides integration with all many AWS services like CloudWatch, and now also it provides integration with Amazon OpenSearch, right? So through zero ETL, and also export to S3, right? So how does it provide resilience capability, right? It basically across 3 areas: infra failure or varying workload demand and system modifications. So since it's a serverless, right, you don't need to worry about the downtime from patching or upgrade or maintenance. It is handled by AWS behind the scene without any impact on your side. And by default, it's 3 AZ redundancy, right? The data is by default, it's distributed across 3 different AZs. And uh, from varying workload, right? For capacity management with on-demand capacity mode, it can provide you, right, kind of hands-free scaling, right? It's instantly scale as per your workload demand, for example, flash sale or maybe Super Bowl event, right? When a lot of users coming to the websites, right? It can scale from zero to theoretically no limits, right? Basically twice the time of the last uh, peak capacity, all right? On-demand capacity mode provide pretty hands-free instant scaling for your workload. So you don't need to manage capacity and workload become resilient. For provision capacity mode, right? Although you pre-provision the read-write capacity in DynamoDB, but you can create auto scaling, like depending on the alarm, it automatically scale, maybe not as quickly as on demand, but you can basically have some scaling mechanism for on demand for auto scaling capability with provision capacity mode, right? So you can use some kind of trigger auto scaling mechanism through the CloudWatch alarm based on your resource usage, and it will create scaling target and update the table capacity. You can implement some kind of automation here. And from the backup durability also, it provides point in time restoration capability, right? It can basically within 35 days, you can go back to any second to point in time recover. And you can also take scheduled backup for long time archival or on-demand backup for before any changes. So those are the in-region capabilities, right? What about global or cross-region resiliency? So DynamoDB provides a global table capability that provides multi-active, multi-region. For example, you can have multiple table across regions, read write from any regions, right? And it's active architecture with 5 nines of availability. You don't need to do any failover. All you need to do is health check, implement health check, and if there is any issue in any region, you switch your traffic to other region, or you can write for multiple regions depending on your workload, right? So with that, I'll hand it over to Sujan to walk us through a couple of architectures on with the resiliency and capabilities here. Okay.
Yep, thank you, Zakat. So let me just share my screen. I hope it's visible.
Yep.
Yep.
Okay, yeah. Hey, good afternoon. This is Sujan Ghosh from IDEXL. And just to give a one-liner about my roles and responsibilities as solutions architect, working with IDEXL for last 14 years. And to give a very quick intro about IDEXL, we are based out of London, founded in 1998, almost like 25, 26 years in the business, and provide professional services and technology solutions for our clients. And who are our clients? Generally the public sectors, non-profit, and the commercial. Definitely, we are in the commercials, and our prime customers are the fintechs. We are the large fintechs we are having as our clients, and also we have a small footprint with the Fed, and we are trying to increase our footprint through various contract vehicles. And also we are AWS advanced partners for over last 4 or 5 years. So that's a quick intro about ITXL. Okay, so the core services, the cloud services, when we talk about the cloud services, is the cloud-based development, migrations, then the data platform implementations, and the AI and the automations. Now let's come back to the subject which we were discussing. You have heard what Sekat has mentioned about that AWS RDS, Aurora, DynamoDB services, its capabilities and its features. Where is it going back? So now I will just go through 3 of the implementations done by us for 3 of our clients. All the 3 examples goes to the fintech clients, but the implementation patterns are slightly different. But before moving on to the implementation detail, just to have a quick recap, when we talk about resiliency, what should we take care of? So resiliency generally covers two things, the high availability and how quick we can recovery from a disaster. So high availability, definitely in AWS, when we talk about high availability, it covers the AZs. So we have to make our database multi-AZs, and definitely on the disaster part and the availability, we can also go for the multi-regions. And also other important factors which covers up the availability performance definitely are the blue-green deployment, implementation of the RDS proxy. So depending on our usage, like what the client wants, how much they can spend on the infrastructure, what are the client bases. Based on different aspects, we can architect what's going to be the high availability and the disaster recovery patterns for the implemented architecture. So now let's go into some of the implementations. So this is for one of our clients, which is growing, have got smaller client base, and also the application is evolving. So we are still, the application is still evolving, being implemented. So what is happening in this architecture? So this is a complete serverless architecture. So it's a Lambda based code and the ECS based code, which are running on a single region. The reason I said single region because it's still evolving and have a small client base. So cost is definitely a factor here. So keeping all those things in mind, the client wanted to go for a smaller footprint on the infrastructure, but with an option to scale up and to failover and fail back. So what has been done? This is a serverless architecture. So you can see the lambdas connecting to the database. And what has been done on that database? It's definitely a multi-zone database on a single region with a read-write instance and a read replica. So what can happen here is all the write operations can go to one of the instance and all the read operations can go to the read replica instance. So this definitely gives a higher performance and also a higher availability. And on this region, it is supported by the AWS backup. So when we say supported by AWS backups, the jobs are scheduled, it takes the AWS backups and keeps it. Now, when I say it keeps the backup, so what has been implemented here is it keeps the backup on the region 1 and also on the failover region. So what happens during any kind of incident? For any kind of incident, this being a serverless architecture, switching to the other region is just a matter of time. It doesn't take much time to switch over to the other region. But the issue is the data. So in case of failure, copying the database back up to the other region, then restoring, that might take a lot of time. So the data snapshots and the backups are already there in the other region. So just restore it and connect it to the application. Though there may be some downtime, but it's relatively faster. So what are the pros and cons of this one? So the pros are definitely if you have an evolving, a smaller footprint, lesser clients, and where cost is a factor, definitely this is an architecture to go into. But the cons, yes, it has got a higher RTO, higher RPO, and it primarily suits a low critical or a dev test application, which where the SLA is low, the SLA doesn't impact much. For those things, we can choose this type of architecture. But what happens when there is a tight SLAs? So let's figure what is in this. So when we talk about high available and highly resilient architecture. So this is a multi-region architecture. So when we say the multi-region architecture, I can see on the left hand side, this is the east 1, and on the on the right hand side, we see the east 2. So what is happening is the code sits on a EKS cluster. As we all know that EKS is the container-based scalable service provided by AWS. So based on the demand, my code can definitely scale. But what happens onto the database? Now, the database is again a multi-region cluster, which is an Aurora global cluster with a multi-AZ deployment, where we have the primary, the read-write instance and a read instance. And on the other region, we have the read instances. So that's how a multi-region Aurora global cluster works. It allows read-write in one region and a write in the other region. But now they have also implemented something called a write forwarding. So when we talk about write forwarding, how does it help? So let's say a user's request comes into region 1, because this being a scalable and being controlled. So as of now, we have an 100% traffic coming in the region 1 and a 0% traffic going into region 2. Let's say we make it 75-25. So what happens? 75 can come into region 1, 25% traffic can still go into region 2. And when we talk about traffic, it can either be a read or the write instance. Sorry, the write requests. So with the Aurora write forwarding, what happens is on the region 2, whenever a write request comes in, it can still forward the write request to the primary cluster on the region 1. So that's an implementation pattern which AWS has brought in, which has been implemented for MySQL for quite some time and has been implemented on Aurora Postgres, not very long, but still. So now coming back to this architecture pattern again, this is like 100% traffic going into East 1 and a 0% traffic going into East 2. Now, what happens in case of a failure, an incident? So what we can do is this being implemented using a Route 53 as a weighted pattern, we can just switch the traffic from 0 to 100 on the East 2. So all 100% traffic starts coming onto the East 2 region. But what happens to the database? The database on the East 2 is still only the read instances. So AWS provides a Aurora cluster APIs. So just with a call of one API, we can switch the database from East 1 to East 2, and it takes hardly about five minutes. So we still can completely switch over from East 1 to East 2 in case of a failure, maybe within 5 to 7 minutes. And the data being already replicated, my RTO. So let's go back. Now let's come to this pros and cons. So yes, my RTO and RPO is now very low. Now, also, it can be supported by the AWS backup. So I still can keep the backup for a desired amount of time. It gives us a geographical redundancy. So when we say geographical redundancy, let's say when I go back to this architecture, I can have my regions like in East 1 or East 2 or maybe West 1, West 2 or somewhere else. So it doesn't matter like which region I choose, my database to be highly available and fault tolerant. Also, the data replication between regions is a very low latency replication. Within few seconds, whenever a data is written onto a primary cluster, it gets replicated to the other regions instances. So implementing a simple automation, we can switch from one region to other region in a very short amount of time. But what are the cons? The primary con is when you say this and compare it with a single region implementation, it is comparatively complex. So you need to understand how the services work, what are the service capabilities, are there any kind of shortcomings, what exactly do you need? So based on all those factors, we can implement a highly available database in using multi-region implementations. Now, this is like a implementation pattern for traffic going to one region primarily, which is 100 and 0. Now, if what happens if we need an application where the traffic must go to both the regions? So this is one of the implementation where we have single sign-on implementation. Single sign-on has been implemented here again with an EKS, which is scalable, because on these applications, there are thousands applications which authenticate to our single sign-on. So the EKS is scalable, and on the back end, we have the DynamoDB. And advantage of using a DynamoDB is we can write and read from all the regions where the DynamoDB is implemented. So as you can see on the top, the traffics are 75 and 25%. So a user's request can come to any of the region. They can read, they can write, and the data gets synchronized between the DynamoDB global tables within seconds. So it is high level and very high resilient architecture using the AWS databases, which has been offered as the inbound services. Oops, that's all. And the cons, as it has been mentioned, it's a very low RTO RPO. We have the AWS backup as an additional service, active multi-region architecture where both read and write happens, redundancy is over multiple regions, it can even be across countries, and it's a fully serverless, so almost zero maintenance on the DynamoDB. But yes, there's one short cons. If, as Saikat has already mentioned, that there are both provision and on-demand implementation of DynamoDB, if it is not planned properly, it can cost you slightly additionally. But yes, once planned, the cost can always be in control. Yep, that's all from me, and I switch it over to Saikat.
Thanks, Sujan. So we have about a couple of minutes, so we'll just quickly take a look at the demo, right? So those who are familiar with the Aurora platform, right? So they might be already aware, but for who are just getting started, so I'm in my AWS console, and what we see here, basically, we have three region deployment, right? We have the secondary cluster in US East, and we have primary cluster in the EU West, and US East 2 will have the another secondary cluster, right? And I want to do a switchover or failover. How easily I can do that, right? So for example, if you go to the global database setting, you get the option to do switchover or failover, and you can do that from API or CLI as well, right? So once you choose that option, you'll get an option to do switchover, and you also get an option to failover. So let's understand the process and when to use what. So switchover basically help you transition the role. So if I do a switchover and I choose that I want to promote maybe Northern Virginia as a primary, what will happen? Northern Virginia will become primary, other two regions will become secondary, will ensure zero RPO, will ensure zero data loss, and will ensure the data gets replicated back to the other two secondary clusters. If I do a failover, that means we'll choose this, and there may be a data loss as far as the replication delay. Then we'll take snapshot to reinstate the other secondary. And usually this is applicable when the primary region really goes down. So we continuously health check, the region comes back, and we rebuild the secondary once the original primary region comes back. So for this example, I'll just choose Northern Virginia to be primary. So I'll choose confirm, and it will kick off the backend workflow. And as you see, it will show the progress, right? And within couple of minutes or few minutes, we'll see that switchover completed, and you can go to the cluster instance, and you can basically go basically and choose open the status and check the logs to see the status, right? So as I'm going here in the instance level, right? And I can go to the logs and events, and yeah. So as the switchover process completes, right, I can come back again, but quickly wrap up some of the capability or tools that can help you, right, with understanding your resiliency, right? Something called well-architected framework that goes through the best practices, right, of your architecture. So I think to get started, to assess your current architecture, identify the resiliency gaps, and build a more resilient architecture. This is a tool. Sujan can post that tool link in the chat box, right? So this is a tool from AWS. It's a self-service based. You can answer the questions on your current architecture. It will generate a report. What are the gaps and how you can make it more resilient? And you can do these checks on specific pillars, right? As you understand, there are performance efficiency, there are cost optimization pillars. For resiliency, you may want to focus on the reliability and maybe operational excellence and performance pillars. So with that, since we are over time, so how you can build a more resilient data architecture, right? So definitely leverage the well-architected tool, generate a report, understand the gaps, and improve the architecture. Maybe it's multi-AZ, maybe implementing backup, maybe changing backup retention, or maybe leveraging DynamoDB global table. So reach out to your AWS account teams or certified partners like IDEXL for additional guidance and programs. And then for today's sessions, if you can fill up the survey link, it will help us do similar sessions in future, improve the content, and cater your needs on building better data platforms, right? So we can post that link in the chat also, right? So, and if I go back to my console, right, and we can see it's maybe 75%, right? You see the switchover still in progress. It may take a minute or so more, but you can definitely check the instances, logs and events, right? On the cluster level, right?
Yeah, so it takes about 5 to 7 minutes to switch over. So
Yeah. So, but
don't think
you
we
can
can wait.
monitor the logs, right? The global
Yeah, we
DSU
can always monitor
start,
the logs. Yeah.
right? So you can definitely monitor once it will finish, you'll be able to see the switchover completed, right? So how easy is that to rotate your workload? And similarly, failover should finish much sooner because we don't need to maintain the RPO 0 here, right? So that's pretty much for today's session. So appreciate the feedback and appreciate if you can fill up the survey, and maybe you get started with the well architected tool. And it's a self-service tool. You can log into your account, and I can show that here as well. If I type well architected in a AWS account, you can see the well architected tool comes up, and you can start your assessment here, right? You can define your workload, name your workload, and you start your assessment with resiliency checks. So we don't have a time to go through that, but maybe that's a good topic for next session. That's pretty much from my side. I'm posting the survey link here for everyone.
Yeah, thanks. The survey link is pinned in the chat if you are watching this on YouTube. So you can
Excellent.
click it and take the survey.
Yeah, thanks, Saikat and Sujan. Appreciate your time, and we'll look forward to the next time we can have you on.
Thank you.
Obi, any final words?
One last reminder to like, subscribe, take the survey, and we will see you all next time.
Thanks, everybody.
Yeah,
Take
sure.
care.
Yeah, thank you all.
Bye-bye.
Okay, stream is ended.
Great.